Question number 1. We have x over y minus x to power -2 minus x plus y squared minus 4xy over x squared minus xy squared times x to 4 over x squared y squared minus y to 4. Okay, so as always, first of all, let's find out domain. For domain, x cannot be equal y, right? It's obvious, otherwise denominator becomes 0. X cannot be equal 0. Y cannot be equal 0. Okay. So, let's start simplification. So first thing, I'm going to flip this -2 exponent, which is going to be equal. It's going to be y minus x squared divided by x squared. I separate it. So look here, if I would open parentheses, x and squared, I got here x squared, and y minus x, again squared, and here I got squared. Yes? Okay. All right. So, minus. Let's open this square here, x squared plus 2xy plus y squared, right? It's the a plus b squared, and minus 4xy divided by x squared minus, okay, let's take in denominator, might as well take x out, common factor, x minus y, and all this squared, and times x to power 4 divided by, here I'm taking y squared, it's a common factor, x squared minus y squared. Okay, so let's combine like terms, this one and this one, right? And we are getting y minus x squared, I'm opening up, y squared minus 2xy plus x squared over x squared, and then minus, we have x squared minus 2xy plus y squared divided by x times x minus y. Okay, squared, and times, well, this term is without changes right now, just moving over. All right, next I'm going to leave the first fraction the way it is, y squared minus 2xy plus x squared over x squared minus, now in this case, x squared minus this one, x squared minus 2xy plus y squared, I'm going to write down as an x minus y squared, right? And in denominator, I will have x times x minus y. And right away, I'm going to cancel here this square with x minus y, correct? Okay, and times x to 4 y squared times x squared minus y squared. All right, so what we have now, finally we are going to bring two common denominator, right? Common denominator is going to be x squared, which means here I need since I have only x left, I need to multiply by x here, I need to multiply by x here. Yes, and it's going to be y squared minus 2xy plus x squared, in opening parentheses, x times x is x squared. Now let me remind you one thing. Negative sign in front of fraction you treat as a negative sign in front of parentheses. Therefore, it's going to flip my signs. So x times x was positive x squared. It become here negative x squared, right? And x times negative y, right? It's going to be negative xy. Here x times negative y, it's going to be negative xy, but because of negative sign in front of fraction, it will become here positive xy. Yes? Okay. And we divide by x squared. Let's put parentheses. And times x to 4 y squared x squared minus y squared. Okay. So what do we get here? X squared is gone with this x squared, and negative 2xy and xy, it's going to be like term. And as a result, we are going to get y squared minus xy over x squared. This is squared times x to 4 y squared x squared minus y squared. Well, if you want, I can put here dots so you won't wonder if it's x or multiplication here. All right, so from here we are getting, let's do multiplication. So y squared minus xy, if I take y out, I will get y minus x, right, over x squared. Now if I want to distribute this square here, it's gonna make this y will become y squared and y minus x will become squared. I distributed that square. And this x squared will become x to 4, right? Because of this square. Okay. As always. Not to threaten some the confusion with some confusion or not understanding. I'm just going to go slow. Minus y squared, and from here I can write down, now I will open parentheses, y squared y minus x squared over x to 4, and multiplying, this is gonna be here x to 4 times y squared, and x squared minus y squared, I'm opening x minus y, x plus y. Yes? Okay. This is interesting. Let's cancel y squared, y squared, and look what we have. Y minus x squared, and in the denominator I have x minus y. So what I'm going to do is, let me cancel this x to 4 also, have it out of way. I'm going to put negative sign in front of fraction, and y minus x squared, here in denominator x minus y, I put as a y minus x, right? Because x minus y is equal negative sign y minus x. Let's open it. Let me show you that that is true. So opening parenthesis, negative y plus x, or I can put positive 1 first, negative 1 second. Okay, so because y minus x is not the same as x minus y, 3 minus 2 or 2 minus 3, correct? This is positive 1, this is negative 1. So obviously it's not the same. So therefore I put negative sign in front of a fraction and switch x with y. Yes? So I can cancel. Okay, and get y minus x and x plus y. And from here, I'm getting this square is gone with this. Okay, and now I can bring back y minus x to not to have the answer negative. I'm going to switch again x minus y here, and negative sign is gone, because if I put another negative sign, so with this negative, it's going to be positive. And I will have x plus y. And this is going to be our answer. Next one. We have radical degree 4 from x cubed minus radical degree 4x over 1 minus square root x plus 1 plus square root x over radical degree 4 of x, okay, squared times 1 plus 2 over square root of x plus 1 over x to power negative 1/2. All right. So, first of all, domain. And for domain, we have only two conditions. X has to be greater than 0, right? Because we have radical. And x cannot be equal 1 also. Look here. X cannot be equal 1. Otherwise, 1 minus square root of x, we are getting 0. Those are two conditions that we have. Let's start working. So, first fraction, the radical degree 4 from x cubed minus radical degree 4 from x. I clearly can take out radical degree 4 of x, right? And what will I have left here? I will have radical degree 4 x squared, because we had here degree 3, x to power 3. We took out x to power 1, the degree 2 stay underneath. Yeah? And minus 1, right? And all this divided by 1 minus square root x. Okay, next plus. For now we leave it alone. 1 plus square root x over radical degree 4 of x, and to power 2 times. Bringing to common denominator the second parenthesis, square root x and x, so it's going to be x, right? If it's going to be x, that means here we divide by x. We have to bring every single denominator to x, right? And here, when whatever change we do to the denominator, we have to do to numerator. Since second fraction we have square root of x, we have to multiply by another square root of x to get x, which means here also square root of x. Well, first fraction we have x, so we don't touch. And we are getting x, here will be x plus 2 square root of x plus 1. Change color. All right, and this is to power negative 1/2. Okay, this is going to be equal radical degree 4 of x. Here we have this one. Look here, radical degree 4 of x squared. It's the same thing as a square root of x, right? It's equal x to power 2 over 4, which is x to power 1/2. X to power 1/2 is square root x. So we are getting here square root of x minus 1 over 1 minus square root of x. Okay? Plus 1 plus square root of x. Here we have radical degree 4 of x squared and times. So we have here negative 1/2. So I'm flipping the fraction to get positive 1/2. And it's going to be x comes to numerator. Square root x plus 1. This is going to be square, right? A plus b squared. Look here. Square root x squared plus twice square root x times 1 and plus 1 squared. So it's going to be square root x plus 1 squared. And this is to power 1/2. Now, what is interesting here, I'm looking, I have square root x minus 1, and I have 1 minus square root x. So how I'm going to deal? Very easy. Adding here negative sign. Okay, let me add this color so you will see changes I'm doing, and canceling these two, right? Because adding negative sign, I'm switching either 1 minus square root of x, or in denominator I put square root x minus 1. The bottom line is they are canceled, they are gone. And we have equal negative radical degree 4 of x plus 1 plus square root of x over radical degree 4 of x plus, okay, actually multiply. So let's put here x to power, distribute this 1/2, x to power 1/2 and square root x plus 1, 2 times 1/2. I distributed this 1/2 to here and to here. Yes? Okay. So we are getting negative, negative radical degree 4 x plus 1 plus square root of x radical degree 4 of x, and this is squared, and times this x to 1/2, it's going to be square root of x, and here 2 times 1/2, this will cancel, and we are getting square root of x plus 1. Okay? All right, let's keep going. So now the first parenthesis I'm bringing to common denominator, which means here I will have radical square root 4 power from x, and here also multiply by radical degree 4 of x. All right, and we are getting radical degree 4 of x. Here we are getting negative square root x. How I'm getting square root of x? Okay, let's see. This negative sign, it's clear where from, but degree of 4 times radical degree of 4, we are getting x to power 1/4 times x to power 1/4, which is equal x to power 1/4 plus 1/4, right? Because when base is the same and we do multiplication, we add exponent. And this is going to be equal x to power 2/4, which is going to be equal 1/2. And that is square root of x. And that's how I got the square root of x. Yes? Okay. So it's going to be negative square root of x plus 1 plus square root of x. And all this, it's going to go to power 2. And times square root of x and square root of x plus 1. No changes there. All right, getting close to the end. And what do we have here? What can I do with this situation of this fraction? Oh, there is nothing to think. Negative and plus canceling, and we have 1 over radical degree 4 of x to power 2 and times square root of x over square root of x plus 1 from here. So if I distribute this square on first the parenthesis, we are getting 1 squared is going to be 1. Radical degree 4, if I raise to power 2, I will get square root of x, right? I already went through drafting here about a minute ago. And times multiplying square root of x, and here square root of x plus 1. So from here, this is gone with this, and we are getting 1 over square root of x plus 1. Now, we cannot leave square root or radical, as a matter of fact, in denominator. Just like we can't leave solution in the form of negative x. We have always to convert to positive x. Same thing is this one. Therefore, what am I going to do? How I'm going to get rid of this square root in denominator? 1 over square root x plus 1. Look, if I take the square root to power 2, square root is going to gone, right? Therefore, since I have here square root x plus 1, I'm going to add square root x minus 1. So this way a plus b, a minus b, and I will get a squared minus b squared. So this way I square my radical degree 2 and square root or radical, same thing, will be gone. Okay, so same multiplication I have to do here. And I'm getting square root x plus 1 times square root x minus 1. I'm getting x minus, oh, yeah, x minus 1. And here I'm getting square root x minus 1. Or you can flip, you can rewrite 1 minus x, and here will be 1 minus square root x. Because look, 1x at the one negative sign, that will change this one, and then another negative sign which will make plus, change this one, right? So when you flip both numerator and denominator, you don't need negative sign in front of fraction because it will become positive, negative and negative. Yes? And this is our answer. Moving to next and last in this video, m squared minus 1 over n squared to power m times n plus 1 over m to power n minus m divided by n squared minus 1 over m squared to power n times m minus 1 over n to power m minus n. Okay, let's start working on this. Domain m cannot be equal 0, n cannot be equal 0. Okay, what kind of changes we can do? First of all, I'm going to bring to common denominator. Okay, every single parenthesis. That's the first thing I want to do, because there is nothing else to simplify or do. So therefore, the only thing we're going to do, bring to common denominator. So it's going to be here n squared all right, here I will have m squared n squared minus 1, yes, to power m multiply by denominator gonna be m, therefore in numerator I will have n m plus 1, and it's gonna be to power n minus m. Okay, now in denominator I'm going to get m squared, here will be n squared m squared minus 1 to power n times denominator is n, will be m n minus 1 to power m minus n. Okay, so what we are going to do next, bringing distributing this power, every single power that they have here, this one, this one, this one, this one, because for now I'm looking, there is nothing else I can do, so I just keep simplifying, working with exponents. We'll see where it will bring us. so what do we have here? We're going to have, so n squared to power m, right? N squared, power to power. So it's going to be n to power 2m, because we multiply by each other, correct? Here will be mn, okay? I'm going to distribute m squared, n squared minus 1 to power m. Next, this one, m to power n minus m. Yes? Same thing, to numerator nm plus 1 to power n minus m. Next, I have in denominator m to power 2n, and I have n squared m squared minus 1 to power n. Yes? Times n to power m minus n, and in numerator we have mn minus 1 to power m minus n. Yeah. M minus n. Okay. Next. Now I see something I can open. In numerator m squared n squared minus 1. I'm going to open it up. Okay. It's going to be mn minus 1 to power m times mn plus 1 to power m. Yes? This one that I broke down into this case. And since I'm going to divide this the first fraction, this fraction I'm going to divide by this fraction at the same time. So this n squared, n to power 2m comes here. And when I divide two fraction in denominator, what's going to happen? This m to power 2n comes to numerator, and this n squared, m squared minus 1 to power n, I'm going to open as nm minus 1 to power n times nm plus 1 to power n, right? As a squared minus b squared. Yes? Okay. And all these I'm going to multiply same way, n m plus 1 to power n minus m. Here I will have m to power n minus m, and when I divide by fraction in denominator, n to power m minus n will come to numerator, and times n mn minus 1 to power m minus n. So let's see, what do we have here? You see here subtraction of its exponents. I'm going to separate them using property of division. Yes? Okay, just to remind you, a to power the m divided by a to power n is equal a to power m minus n. Now I'm going backwards. From here I'm getting to this format. Okay? All right. Why am I doing this? If you wanna ask me, because I see here mn minus 1 to power m, mn plus 1 to power m, right? So if I separate them, I can cancel them. That's why. Okay, let's work on it. Mn minus 1 to power m, mn plus 1 to power m times m to power 2n divided n to power 2m and m minus 1 to power n times nm plus 1 to power n times, now here, n minus m, I'm going to break it as nm plus 1 to power n and divided by nm plus 1 to power m. Yes? Okay. Now, same thing I'm doing in denominator. mn minus 1 to power m. And when I divide, it's gonna be, because it's a fraction, right? If I divide right down here, let's say mn minus 1 to power n. So when I divide on by this fraction, this denominator gonna go up, right? Therefore, this is what I will do. Just write down, might as well here, mn minus 1 to power n, and clean it from here. Okay. Next, we have here m to power n minus m. Same thing I'm doing here. Times m to power n. Divided m to power m comes here. And same thing, n to power m stays on the top. And n to power n come to denominator. Okay? If something is unclear, you can place your question in the comments and I'll gladly answer. Okay, so let's see what is disappearing. Mn plus 1, oh, this one is gone, right? Mn minus 1 to power m, this one is gone with this one. Okay. Nm plus 1 to power n, this one gone, and this one gone with this. Okay, so let me write down clean, because before we move further, see what else we can do. Because it looks messy, so not to leave out anything. M to power to n, m to power m, n to power m. This is what we have in numerator left. N to power to m times m to power n, and times n to power n. Okay. So we have same base, this one and this one, so I can combine, right? Can I? No, I don't. I changed my mind. Because, let me see, n to power, yes. Look, I have n to power m, which will be gone. And here 2m, only 2 will be gone. I will have n to power m left. M to power n, this will be gone. Here will 2 gone, because 2n minus n will be 1n, so m to power n will stay. And I will have m to power m times m to power m over n to power m times n to power n. So, oops, this is n. And this is equal m to power n plus m. Here I have n to power m plus n. Let me fix these colors. And from here we get m over n to power n plus m. And we are done. This is the answer. All right. So thank you very much for watching. And I'll see you as always. Where? That's right, in next video. Okay.